In this lesson, we're going to talk about how to find the area under a curve. So if I'm looking at a graph, how do I find the area that's bounded by a region? And in the first part of this lesson, we're going to learn how to do this using rectangles to approximate. Okay, so what I want you to do first is pause the video, and I would like you to graph this region. And then we are going to find the area of that region, and notice that I'm only looking at the first quadrant. So the first thing we need to do is graph our equations and see what kind of region we've got. So y equals 2/3 x is a line with y-intercept at the origin and a slope of 2/3. I'm not going to do this real exact, but we've got this line with a positive slope going through the origin. The line x equals 5 is a vertical line that goes through the number 5 on the x-axis. Okay, so and in the first quadrant, bounded by those two lines, we've got a triangular region. So if I wanted to find the area of this triangle, okay, then I just need the formula for area of a triangle, which is 1/2 times base times height. Okay, our base on this triangle is 5 units long because it starts at 0 on the x-axis and stops at 5. Our height, however, is the y value because it is this side, this vertical piece of this line that's going straight up. So we need to find what the y value is when x is 5. So our y equation was 2/3 x, but we are looking at when x is 5 to figure out what this distance is. So 2/3 times 5 is 10/3. And when I multiply those together, I'm going to get 50 over 6, which reduces to 25 over 3. So if I graph my region and it turns into a geometric figure, like a triangle, a trapezoid, or a rectangle, then I could find the area pretty easily using my geometric formulas. But what if my region is not a geometric figure? So pause the video for just a second, and I want you to graph f of x equals x squared plus 2, and shade in the region bounded by our equation f of x, the x-axis, the y-axis, and the line x equals 2. Okay, you should have ended up with a graph that looks something like this, and the region then would be all of this part between the x-y axis, the line x equals 2, and this parabola. Okay, so I'm trying to find the area of that region. Okay, I can't just apply a geometric formula because I have a curved piece to this. So what I'm going to have to do is approximate the area, and we're going to use rectangles, and there's 4 different ways to approximate area. Left-hand sums with rectangles, right-hand sums with rectangles, midpoints of rectangles, and then trapezoid formula. We're only going to work on left and right-hand sums in this video. Okay, and notice it tells us to use 4 partitions of equal width. So I want to split this up into 4 sections. Okay, so how do I know how wide they should be? Okay, well, let's look at our x-axis and let's see what we're going from. So we're starting at 0 and we're ending at 2 because we had that line x equals 2 as one of our boundaries. Okay, so my total width for the whole region would be 2 minus 0. But I want to split this into 4 parts. So I'm going to divide that by 4. So I'm going to make rectangles with a width of a half. Okay, so an in general formula for this would be b minus a divided by n, where n is the number of partitions or the number of rectangles you're going to break this up into. And then b and a are your x values, where your graph is starting and stopping. Okay, so I'm going to split this up, and so every half, so from 0 to a half, I'm going to draw a line there at 1, at 3 halves, or 1.5, and then at 2. So now I've got 4 partitions here. It's broken up, and the width of these partitions, again, is 1/2. When you're drawing these graphs, do yourself a favor and make them large enough that you can see what's going on and what read your numbers. Okay, so all of these have a width of a half. Okay, now we said we were going to use rectangles, so I somehow need to make these 4 sections into rectangles, and it says to use a left-hand sum. So left hand means I'm going to take the line that's on the left side of this partition, and I'm going to flatten it out to make a rectangle. So on this first one, I'm going to call this area 1 because we're going to find the area in a minute. Okay, so I want the left side, so that's where x is 0. So I'm going to come up here on the graph, and I'm going to flatten it out. So I'm actually finding the area of this rectangle in blue. Okay, for the second one, again from the left side, I'm going to go to the graph, I'm going to flatten from the left side. So I'm finding the area of that rectangle. Okay, for the third one, again, I'm going to flatten it out from the left. I'm going to start on the left side and draw a line straight across to make my rectangle. Okay, and then for the fourth one, again, I'm going to make a rectangle starting from the left side and going straight across. Okay, so now I've got 4 rectangles in this picture. And I need to find the area for each one, and then I can add those areas together and it will get me close to the area of the whole region. Now I want you to notice that this is going to be an underestimate because we're cutting off all of these parts that I'm shading in green. That's part of our original area we wanted, but we're not going to include that in our estimate. So this is going to be an underestimate. It's not quite going to be high enough, but remember we're approximating. Okay, so what is the formula for area of a rectangle? Formula should be, if I'm using rectangles, the area is length times width. And we already said the width on here was 0.5. Okay, so what is our length? Well, our length is going to be this side over here. It's the y value, okay, when x is 0. So how do I write that out? F of 0. So I'm going to do 0.5 times f of 0. Okay, area for rectangle 2. My width is still 0.5, but now my length, or my height here, is going to be f of 1/2. Okay, because it's where this point is. This is 1/2 on the x-axis, so f of 1/2. Okay, for my third rectangle, my width is still 0.5, but my length this time is going to be my y value when x is 1. And then for my fourth rectangle, I'm going to have 0.5 for my width again, but my length is going to be the y value when x is 1.5 or 3/2. Okay. Okay, so now how do I calculate those areas? Well, how do I do f of 0? To do that, I'm going to have to plug 0 into my original equation. Remember your original equation, f of x was x squared plus 2. So when I plug in 0, I'm going to get 0 squared plus 2, which is 2. So I've really got 0.5 times 2, which is 1. Okay, to do f of 1/2, I'm going to plug in the 1/2 into my equation. 1/2 squared is 1/4 plus 2 would equal 9/4. Okay, and then times another 0.5. 9/4 times 0.5 should come out to be 1.125. Okay, plug in 1. 1 squared plus 2 is going to come out to be 3. So 0.5 times 3 is 1.5. And then we're going to plug in 3/2. 3/2 squared is 9/4 plus 2 would come out to be 17/4. Okay, times 0.5 comes out to be 2.125. Now you can do this in fractions or decimals. I'm not picky on this, but I do want to see all of your work. So now, how do I get my area approximation? Well, I'm going to need to add all of those areas for each rectangle together. So I'm going to do 1 plus 1.125 plus 1.5 plus 2.125. And so my approximation for my area is 5.75 units squared. And remember, we said that was an underestimate. So the actual area should be something a little larger than that. Okay, now let's look at the second method. The second method are rectangles with a right-hand sum. Okay, I still want to use 4 equal partitions, so let's break this up into 4 parts of equal width. So my width is still going to be 1 over 2. Okay, but this time when I draw my rectangles, I'm going to start from the right side. Okay, so here's my regions. And on the right side of this first one, I would be, instead of at 0, I would be using an x value of 0.5. Okay, so I'm going to flatten this out to make my rectangle. For area of the second rectangle, when I flatten from the right, then I'm using an x value of 1. I'm going to use f of 1. Okay. On area of the third rectangle, I'm going to be using 1.5 or 3/2. And then on the fourth rectangle, I'm going to be using 2 as my I'm going to find f of 2 to use for my length. Okay, now notice this time my area is above the curve here. So all this part that I'm shading in is not actually part of the area that I want, but it will be included in our estimate. So this one is going to end up being an overestimate. I'm going to have a number that's too high. So the first one gave me a number that was too low. The second one's going to give me a number that's too high. Our actual area would be somewhere in between. Okay. Now I'm going to write this out a little bit differently because I'm going to add them all together as we go. Okay, so for the area of rectangle 1, my width is still 0.5. Okay, and again, to get the width, you can use the formula b minus a over n, where b and a are your x values, where you start and stop, and then n is the number of partitions. Okay, so 1/2 is my width, and then we said we were going to do f of 0.5, or f of 1/2 for our first length. Okay, for the second rectangle, my width is 0.5, and my length is the y value when x is 1. Okay. For my third rectangle, my width is still 0.5, but my length is going to be the y value when x is 1.5 or 3 over 2. And then for my fourth rectangle, 0.5 for my width, and the y value when x is 2 for my length. Okay, now we've already done all of these numbers except for f of 2. So if I plug into, remember our f of x was x squared plus 2. So if I plug in 2 squared plus 2 is going to give us 6. So this is going to be 0.5 times 6. The f of 1.5 we did on the last problem, and we got 4.25. Okay, f of 1 was 3. And f of 0.5, again, we did these on the last problem, was 2.25. So we don't have to calculate everything every time when we're using the same picture. Okay, when you add all or multiply all that out and add it up, you will come out with an answer of 7.75. And again, we said that was an overestimate. So our first estimate was 5.75, which was too low. 7.75 is too high. The actual area is somewhere in between. Okay. Now I want you to pause the video for a second, graph this region, and split this up into partitions, and then we're going to use a left-hand sum. So if you will pause the video for just a second. Okay, so here's what your graph should look like. It's a piece of a parabola the parabola is pointing downward. Okay, on the x-axis, we're starting at 0 and we're ending at 3, and then we wanted 3 partitions. So the width this time should be 3 minus 0 divided by 3, or 1. So to draw our partitions, they're all going to be a distance of 1. So I'm going to draw one at 1 for the x and at 2. Okay, so I've got 3 partitions here. The last one is actually just a point instead of a line going straight up. And we wanted to use left-hand rectangles. So we want the left-hand sum. So I'm going to start from the left side of the rectangle. So for this first one, I'm going to use f of 0. Okay. For the second one, I'm starting from f of 1 and flattening my rectangle out. And then for the third one, I'm starting at f of 2. Okay. Now we need to find the area for each rectangle. And notice this time this is an overestimate. My rectangles go above the curve, so I'm getting too much area. Okay, so for the first rectangle, my width is 1, and my height, or my length, is going to be the y value when x is 0. For the second rectangle, my width is still 1. My height is the y value when x is 1. And for the third rectangle, my width is 1, and my height is going to be the y value when x is 2. Now remember, we have a different equation this time. This time our f of x was 9 minus x squared, so that's what we're going to plug into. So f of 0 would be 9 minus 0 squared, which is just 9. So I have 1 times 9 for my first rectangle. For the second one, if I plug in a 1, f of 1 would be 9 minus 1 squared, or 8. So 1 times 8. And for my third rectangle, my f of 2 is 9 minus 2 squared, which would be 5. So 1 times 5. And when we multiply by 1, it's not really going to change the number. So 9 plus 8 plus 5 is 23. Okay, and remember, that's an overestimate. Oh, sorry, 22. And that is an overestimate because our rectangles actually went above the curve, so it included a little too much area. Okay, now we're going to use the same conditions, but this time we're going to do right-hand sum. So I want you to draw your graph again, break it up, and see if you can set this up using right-hand rectangles or right-hand sums. Pause the video and start when you've got your graph drawn and your partitions drawn. Okay, so my partitions are still going to have a width of 1. Okay, and again, remember, draw these large, because if you don't draw them very large, it's hard to see what's going on. Okay, but this time I want to start from the right side to make my rectangles. So on the first rectangle, starting from the right, that would be f of 1. Okay, so the area for the first rectangle is 1 times f of 1. Okay, for the second rectangle on the right side is f of 2. So our width is 1 times f of 2. And the third rectangle isn't really going to be a rectangle at all because when I flatten this from the right, I just get a line. Okay, so, but it's still, to set it up, it's like saying 1 times f of 3. Okay, f of 1 when we plugged in last time was 8, so we've got 1 times 8. F of 2 was 5, so 1 times 5. And f of 3, remember our function f of x was 9 minus x squared. Well, 9 minus 3 squared is going to be 0. That's why we don't really have a rectangle on that last one. So it's 1 times 0, which is going to give us 0 area. So our area really comes out to be 8 times 5, or 8 plus 5, which is 13. And this time that's an underestimate because all of this that I'm shading in the blue is area that we should have used, but we left off. So this is an underestimate. Okay, so our actual area would have to be somewhere between the 22 that we got the first time and the 13. Okay, now how can we make our estimate more accurate? Well, if we go back to this picture that we just had with the right-hand sums, how could I make that more accurate? How can I not leave off quite so much, whether I'm doing left-hand or right-hand sums? Well, one way to do that would be to make more partitions. So let's say that I wanted 6 partitions instead of 3. Okay, so I would have to split each one of these in half. Okay, and if I were still using right sums, I would still be missing this area, but now I'm only missing this much, so I'm adding this part that's in the blue back in. All of this would be added back in. Okay, and again here, I would be adding some back in. Everything that's in blue, but not shaded over in green, would get added back in. Okay, so there's a lot of area there that I would be adding. And if I split this in half again, then I would be putting back more area. I would be getting closer to the actual area. So the way that you make your estimate more accurate is by using more partitions or more rectangles to find your area. Okay, in these problems, because we're just learning this concept, I will tell you how many partitions to use. Okay. There are a few other methods that are often more accurate than the left and right hand sums, and the midpoint and trapezoid methods are what we will talk about in the next video.